Yep, I think we are live. Thank you very much, everyone, for joining us for another session of Amplifying F Sharp Essential Lectures. And this week is our 8th week of the 12-week course that we have planned for you. And today we are going to be covering functional validation, which is this week. And we will be talking about applicatives, which is something I'm really interested on. So yeah, so before we start, just to let you know, if this is the first time you're watching these lessons or lectures on YouTube, and you might be wondering is where are the rest of the sessions? So if you visit our webpage, which is amplifyingfsharp.io F Sharp Essentials, here you will see the course overview. And so far, we have uploaded all the different videos on the respective sessions. So if you go, for example, the introduction setup, you will see a video, and then the next one, and so on. Yeah. So without further ado, I will hand it over to Ian Russell, who will teach us some F Sharp. And yes, all yours.
Right. Thank you, Edgar. So, yes, session 8. Agenda for today is to do a quick recap on the last session on active patterns because, well, mainly because we're going to use them today as part of the validation, and then we move on to functional validation. We're going to look at applicatives, which sound really scary but aren't that scary, and we're going to do a quick introduction to computation expressions, which are really cool feature of F Sharp. But that's just going to be a very quick. I'm not going to go into detail on those because we've got a session in, I think session 11 or 12 is computation expressions. So recap on the last session. So active patterns, talked about partial and total active patterns. I'm going to have a quick go here. So we'll start off with, so we looked at four core types or 4 core options. So the first one's a partial active pattern. Active patterns use the banana clip, so parentheses and a bar. And then in this case, because it's a partial active pattern, it means that not all of the inputs will produce an output. So not all of them will meet the requirements. So in this case, I'm going to do date time. So I've got that, and I have to put the wildcard in as an option. And then I'll do an input of string. I'll do a quick. In this case, I'm going to use datetime.tryparse. So if I get at the tuple that gets returned from that equals datetime dot tryparse. That's the input in. And I'll just do if success, then some value, else none. So partial active patterns, because they may or may not produce a happy path result, they return an option. So in this case, if it's successful, it returns the value, and if it's not, it doesn't. If you don't want to return the value, you return unit. But in this case, we do want to return the value because we've gone to the we've done the tryparse, so we've got the datetime value out of that. And now to use them, I just do a match expression. So let's pass in a string. So match the input with, and I can just do date, time, which is my active pattern, and I can get the value out. So I need to give it a placeholder to store the data. And then I'm just going to output here's a valid date. Oops. And then cover the other case. Is not a valid date. Okay, so that's the idea of a basic partial active pattern. So an active pattern is just we've already done lots of pattern matching through all of this, but it was all built in. This allows us to write our own patterns. So that's a partial active pattern. So the next one that we've got is a parameterized, and this is the only difference here is that we can pass in another value as well as the value that we're going to test. So if I did, I'm going to look at is divisible by here. So again, exactly the same. So it's a partial active pattern. In this case, I'm going to have two parameters. So I'm going to have a divisor, which will be an int. An input, which will be an int as well. And I'm just going to go if input mod divisor equals 0, then so I'm not interested in any return value here. So I know the value is going in. All I'm interested in is it divisible by? And then if I want to use that, I can do so if I do FizzBuzz, so match input with, so here's divisible by 3, and I can combine these together, so I can use or and. We've already used that or before with the vertical bars, but I'm going to use and, so it's just a single ampersand. So it is divisible by 5, then that returns FizzBuzz is divisible by 3, returns Fizz is divisible by 5, returns Buzz, and I need to cover all the other cases. So I just return string of the input. So that's a parameterized partial active pattern. So it's partial because it's got the wildcard, because not every input will be divisible. And it's parameterized because it has an extra parameter being passed in. And you can see that's the divisor. Next we move on to what they call total patterns. So in this case, we're going to look at multi-case active pattern. And in this case, the input has to match every single input has to be covered successfully. So if we cover odd and even, so if I pass in an int, so if I go odd and even, if I pass in an int, so match actually, I don't need to do match here, do I? I can do a simple if. So if input mod 2 equals 0, then even, else odd. So there's no option on this. This is a, we can see the type there, it's a choice, but you don't really care about that. All you care about is whether you can use it or not. So let is even. So match the input. Oops. Okay, so that's relatively simple to use. And so every input that comes in has to either be odd or even. There's no other option. And obviously then the pattern matching can, if I can type properly, right, then the pattern matching can use the exhaustive checking. So it knows that because there are only two options, then I've covered all the cases there. I don't need to use a wildcard. It's easier to follow that way. And then we have a single case active pattern, which rather than having multiple options has only one. So I'm going to do split here. So if I do input dot split, that will just use the built-in string split function. I can also do a parameterized version of that as well. But obviously they can't have the same name. So if I go to one of them, that's probably the least useful. So this then means that I can pass in a the 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 separator. Forgot what the word is now, but so let's use that. Okay, I'm going to and convert that to a list just so it's easy, just so it's easier to use for me. So I don't need to, if I just want to get at the list, I can just do items. Well, we've got an incomplete map, so it doesn't think there must be some other options as well then. So I'm going to return items. I'm going to return an empty list from that. It tells me it can never be reached. But that's the basic idea of the single pattern. We'll use that in the next section. So no questions on that, hopefully. So that's just a quick recap on what we did.
No questions so far.
Okay, that's just a quick recap on what we did last week. So this week we're going to look at, I called it applicatives, but we don't have to use applicatives. So what we can do here is we're going to take a string which happens to contain some data, and we're going to parse it into an unvalidated user. So it's going to have a name, an email address, a date of birth, and it doesn't look it's a little bit odd with the 2020 as a date of birth, but it doesn't matter. And then I might change that. Actually, it doesn't matter. So what we're going to do is we're going to take that string, we're going to split it, create an unvalidated user, and then we're going to validate that user. So we're going to use some active patterns to do all of this, and then we're going to hopefully we're either going to create a validated user, or we're going to create a in this case I'm just going to create a list of strings of the validation errors. Next week we'll go another step further than this, and we'll do a lot more domain modeling. So we'll get rid of a lot of the strings and date times and things, and hide them behind some proper types rather than primitives like this. And part of that also will be the errors, the exceptions. So what I want to do is I want to do a few steps then. So I need to, so if I call this import, then it's going to take a string. So what I want to do is I want to parse the input, and then validate it. So to parse the input, I'm going to do so I need to split the data. So I'm going to create the, so I can copy the split thing from there. I've got a bar separator. Come back to that bit in a second. So I know this should split into 4 parts. And this should be, so this is the name, email, date of birth, and okay, so I'm extracting the values into those things. I'm now going to create a new unvalidated user. So I've got name, email, date of birth, and discount, which are all strings. So name equals name, email equals email, and discount. Okay, so it thinks that it's going to get a validated user from that, but I don't want to do that. What I want to do is I want to return um, I want an unvalidated user at this stage. So I'm going to, how am I going to cheat?
Yeah, in this case, the compiler by design takes the first that matches with the type, so it will take the
The
validated.
last,
Yeah.
it takes the last, it takes the latest one.
Oh, yeah, sorry,
So
the late.
it's a
Yeah,
date time.
yeah. So you need to force it basically by either put the type annotation or something else.
Yep. That's not going to help me, I don't think. Can I force this?
You can just provide the type annotation at the end of the record. Just column and then the unvalidated user, I think, should work.
Sorry?
On line 45. On line 45, I think if you just at the end put the column and then type the unvalidated user, this should do the trick.
All right.
Yes.
Okay. I learned something. I didn't know that. Thank you. And okay, I'm just going to throw an exception on if there's an error. I don't obviously I'm going to control the input at this stage, so it doesn't really matter what happens. So all I'm doing here is just doing a split, extracting the data and creating an unvalidated user that I get out of it. So that's my first part. So now I need to do the second part, which is the actual validation. So I now need to create some validation functions for name, email, date of birth, and for discount as well. So I've taken some of the ones that I did last time in here, so to save me having to remember. So I've done one for email, and obviously I need the regex from that as well. split. So I need what do I need? I need a non-empty string. I need a date time. I need a decimal, and I need an email. I've got email already. So non-empty string, that's going to be a partial active pattern. I can do if input is not equal to empty string, then date time. I think I did one of those earlier. Let's copy that. Save me having to type it all out again. And then I've got decimal as the last one. Okay, this is another one like the date time. There's another try powers on this. And again, so if success, then some value else none. Okay, so I've created all of my active patterns, and now I want to use them. So I want to create a validation function for each of the inputs, for each of the parts of the unvalidated user. So I just need to create some functions. So validate name. So this is just, I'm doing a non-empty string. So if it's valid, I want to return, what I'm going to do is return a result from each one of these validation functions. So I'm going to return OK input. And if it's not a non-empty string, I'm just going to return a string from this. So that's validate name. And now I need to do the same with email. And email returns some data. In this case, I'm not too worried about it because I can just use the input. It's either a valid email or it's not, so the whole thing's going to be correct. So the next one is date of birth. Okay, again. And in this case, I do need to take the value out because it's obviously converting a date time to a string, to a string to a date time. And then the final one is the discount. It's a decimal. Again, we need the value from it. We need to return the value. Okay, so I've got everything sort of set up, or nearly everything set up. So if I didn't return result from everything, what I could do is I could create a function called validate. Takes an input, which would be an unvalidated user, and it would return a validated user. Yep, that's better. So what I'd have to do is call each of the validate functions in turn. So let name equal input.name, and then validate name. The same for email. And the last one is the discount. Okay, and the last one is I need to create a validated user. So to do that, I'm going to create a new function called create that's going to take name, email, and discount. And I'm just going to create that I can copy. That, but I'm going to expressly set the output type on that to be validated user. Okay, so at the bottom, if I do create, and I just go copy that again, save me a little bit of typing. Okay, so we've obviously got some errors here because we don't have I can't simply pass name etc. in because they're not. That's not a string. That's not a string. That's not a date of birth, and that's not sorry. That's not a date time. And that's not a decimal. We've actually got results, so wrapping them up. So I'm not actually returning a validated user. What I'm actually going to be returning is a result of either validated user or string list. Now, obviously, that won't work currently because we've got a function that's expecting primitives rather than results. So we can already handle some of this because we know how to do things like map and bind, which we can use we can use map and bind from the results module. So we've already seen how to use that in earlier sessions. We're also going to be using partial application here as well, and this is where the applicative part starts to come in. So the idea of this is that what we're going to do is we're going to return we're not going to exit at the first error. What we're going to do is return either a correctly validated user or a list of all of the validation errors that we got. So it won't exit the first one. It will actually handle all of the errors for it. That's the sort of applicative part that we're heading for. So how could we do this? Well, there's the long way we could do it. So we could create a couple of functions. We could create a little function that gets out the errors and then says, are there any errors? If there are, then we return a list of all those errors, and if there aren't, then we write another little function that extracts the value out and then runs our create function. And that seems like a slightly long-winded way of doing that. It's quite a few lines of code to do, and it does work, but it means that we've got to do a lot of work every single time we do one of these. Whereas there must be a much simpler idea, and that's what we're going to try and cover here. But it's a little bit it's not complicated. It's just it just takes a little bit of thinking about. So, no questions on this so far? That everybody's quite happy with where we got to?
No, so far so good.
Okay, right. So now we get the leap of faith, really. So we need to get rid of this. We need to get this this little thing here to work in such a way that it's usable. So I said that we're going to use partial application. So in this particular case, we're going to do. I'm going to put some brackets in to begin with, just to make it more obvious what I'm sort of heading towards. So the first thing we need to do is we need to think about the So we have two parts here. So what I'm going to do is take the create and the name together to begin with. So we have a function that doesn't output a result. So the create function returns a validated user rather than a result. But name is a result. In this particular case, it's a result of string and string. So the first thing we need to do is we need to use the map function so that we raise the create function up to the level of result. So I'm going to get rid of this for a second. So I want to do result.map to begin with. And I also want to get rid of that type as well, because I actually want to look at what's so I'm just going to shift this out the way for the moment. So I actually want to have a look at what's going on. So my function, I know that I need to return a result of validated user and a string list. So at the moment, I've got a result of, and here I've got a function, and I'm returning a string. So I need to return a list of strings for the errors, for the error case. So I'll handle that first. So there are a number of ways of doing this. The simplest way to do it is to make it so that our validate functions return on the error path a list. So I'm going to do that as that's going to be my fast way of doing this. I'm not sure it's the best way, but it certainly does work. Okay, so if I have a look at so that's now returning a result of string or a list of string. That looks a little bit better. So that's the first part. So the second part is so I know I've got a result, and I need to combine it with another result. So I'm going to put the brackets around that for the moment. So this part here is that produces this result of a partially applied function or a list of strings for the error case. And this is a result of string or a list of string. So I need to find a way of combining these together. And to do that, I need to create a new function. And I'm going to call this function apply. And this takes two parameters. So it takes my little partially applied function that's in a result, and it takes the validated result as well. So what I need to do here is I need to cover 4 cases. So I need to cover. So I need to match both of those. So F result is this partially applied function, and that can be either it's okay, and the email result can be okay as well. And obviously what I can do from that is to return that function. Now, it could be that the first part is okay, and the email result could be an error. And obviously in that case, what I want to do is I want to return the error. So I want to propagate the error through. And the other case could be that the partially applied function that we passed in is an error, but the new one that comes in is okay, but that's still, I only want to return the error. And the other case is that they could both be errors. And in this particular case, I need to concatenate the lists. Oops. And I need to okay that. Right, so this first part here, so this result, so if I get rid of that for the moment, so that result.map create name is returning this. So result of, and then you've got the partially applied function. So we've already applied one string, so we've now got the second string, the date, time, and the decimal to go in, and it returns a validated user, or it's the list of strings, which is the error side. So that's this F result. And then the second part of that is the email that I'm going to be passing in. So I can now do apply. So now if we look at the signature of this, it's now saying it's a result of, and it's a partially applied function that's going to take the date time, which will be the date of birth when we get onto that, and the decimal, and returns a validated user, or we get the list of string. Again, we keep going. So I can do I and get rid of that. So we're getting there. And obviously when I do the last one, Okay, when we have a look at that, we've now got my result of validated user or a list of strings. So that now is finished. Looks ugly, looks pretty horrible to use, but it's sort of okay. We can tidy this up a little bit. And what people used to do was, instead of sticking with this particular style, was write some custom operators. I'm just going to quickly show you how that would work. So addition, for instance, is but we can also do so they're both exactly the same. So the first one, the add function, is using the infix operator. So it fits inside the two parameters, inside the X and the Y. And the second one is using the prefix operator. And all that is exactly the same operator, but with parentheses around it. So we can take that idea and create our own custom operators. And standard way of doing this was to use this particular operator for the map. And then we had a slightly different one for the apply function. So what we now do is a little bit of replace. So if I replace the result.map, the prefix operator for the map, and then for the applies, I do the same thing. And what I can now do is use the infix versions of it. And I can get rid of all of the So what I can now do is get rid of all of the brackets. So that's the other version. That's much closer to what we originally started with. So without all the results and everything, when I just wrote the original create function, so like that, and copied it, we're a lot closer to that than we were previously. And what people tended to do is, obviously, if you've got lots of parameters that you need to set, then obviously the stretch is quite a long way across. So you'd often see this. So if you've ever seen that anywhere and wondered what it was, that's all it is. They're just custom operators to do for result.map and for apply. Any questions on that?
No. All good
Really?
for now. Yeah. I think, this is one of the things that once I started learning F# and before F# 6, I think, yeah, this was kind of the way to do validation with custom operators.
Yep. So obviously what I'm going to do now is tell you to, whatever I've shown you here, forget it. So you don't need to forget applicatives. Applicatives are quite useful. There will be situations where it makes sense to use them. So you've got lots of things that happen. You want to combine the results together. They can be useful. But this is not the way that we generally do functional validation now in F#, certainly since version 5. So what I'm going to do is I'm going to copy this. And I'm going to put it onto, and we're going to use computation expressions instead. So we're going to use a library called fstoolkit.errorhandling. So I'm just going to load that in via a script from NuGet. And I'm going to open it so that I can use it. Let's work our way down. So what can I get rid of? Well, I can get rid of apply. I can get rid of all of that. So I don't need it. And this, I'm just going to okay. I'll put that back into its rightful place. So I'm not really going to tell you how this works. I'm just going to show you that it's a little bit easier to use. So what I'm going to do is this. Move that inside there. Right, so this is the validation computation expression. So it's the name validation, and then you've got curly brackets and curly brackets down here. So a couple of things that I need to do. I need to, so far we haven't used the return keyword at all, but you need to use a return in this. And currently we've got the same error that we had before, which is obviously this was expecting name to be a string, but it's not because it's a result of string or string list. And the way to get around that is to use the bang operator, which is just the exclamation mark. So I can do that. And what this is doing is saying, it's effectively using bind under the covers. And what this is doing is saying that it's extracting the value for me. So in the happy path, which is what you can see, what you're doing is if input name is, and you validate it, is okay, then it will extract the name for you. And the same for email, date of birth, and discount. The problem with this approach is that whenever it fails, it will then bypass all the rest of the lines going down, and it will return the first error that gets returned. So to get around that, they introduced another keyword in here called and. So that will do all the 4 validation lines, and then if everything's still okay, it will do the last line, and if it's not, it will return the concatenation of all of the errors. So all that work we did with apply is done under the covers for you here. So that's the validation computation expression. We will look at how these actually work in session 11 or 12 when we look at computation expressions. We won't look at validation itself, but we will look at some of the other ones that we can use.
Right, we have a couple of, I think one question. It's about the create function. It seems like it looks a bit weird. What are you saying is supply some input and let me see if I can read this. So what you're saying is supply some input and you get the validated user out, but any of these input would be invalid. Think it's about line 72. Wouldn't it be better to nest create inside of validate?
You could do. It's just makes it a little bit cleaner, that's all. It's just easier to read, because if you could put all of this into the validation thing. Yeah, absolutely.
Yeah, another thing that I normally do is use anonymous record to I mean, if I don't want to have a type or anything like that, just return a anonymous record as part of the validation. So I will be able just to get the values, but yeah, either ways, I think it's good.
Yeah, at the end of the day, this isn't none of what I'm covering here is saying this is the law.
Yeah.
Yeah, this is how you must do it. I'm just showing you that there are ways of doing it. If there are other ways and you prefer those, then do them. I just know that that this particular style works. It's easy to read. It's easy for people to pick up and to follow.
Sorry, if I may interject.
Yes, please.
So the question I was asking was, if you look at the signature of a create function,
Yep.
Nominally you're just passing some inputs, and at the end of it you get a validated user, right?
Yep.
But if you pass in something that is that doesn't conform to, I think it's a validated user. For instance, you pass a date of birth which is not a date, then it's not a validated user, is it?
No, but the compiler knows that the way that it gets used. You can also specify you can also set the type.
Right. So you would be relying on the fact on the compiler to tell you.
Yep. So if you look at the right hand side here, it's telling me it's a date time, even without because that's how it's being used. Because when you use it down here, it gets extracted out as a date time.
Right. Okay, got it.
So the compiler does a lot of the work for you to save you having to specify the types.
Now, because if let's say somebody doesn't know a code, right? You have lots of code and you have a create method, he might think, oh, yeah, but then again, he would know that he would have to pass in the date time. Okay, fine. Thank you.
Yeah, the compiler will tell you what it needs. You can also, as I said, you can also explicitly set it. That's entirely up to you, but it's it's one of those things where it's where when you're in the editor like this, it's fine, but looking at a piece of code inside GitHub, for instance, all you see is the name. You don't see the type. Was that the only question?
Yeah, I think the last one is just a comment about since we are returning result, then in case of an invalid value, we never get to create and return an error or list of errors.
Sorry, say again.
Since we are returning result, then in case of an invalid value, we never get to create or return an error or a list of errors.
No, return the list of errors.
Yeah, which is what's the result, like validate user or a list of strings, right?
Yes. Yeah, it will always return. So it'll either return OK of a validated user or error and a list of strings.
Yep.
So
So
it'll return one of those.
So let's say the name has been properly validated, so it's valid, but then the email, the dates of birth and this count are not valid, then you will get the result of a list of errors with 3 values inside of the list.
Correct. Yes.
Yeah. Yeah.
Yeah, and that's automatically done for you. You don't need to do, but that was the same with the apply function as well. So the applicative version, it's exactly the same.
Yeah, I linked in the chat the language design notes for this feature that will really explains, why this was done and the reasoning behind in case someone really wants to read what the Donsheim created for that. Right, that's it for us now.
And that's the end of this session.
Oh, nice. Yeah, we really timed it really nice. Yeah, so right, so if there's no other question, let me take back the screen and I'm going to just recap a little bit. Let me.
So next week, what we'll do is we'll get rid of a lot of the primitives from this. So we'll take this as a starting point, and we'll make it much more domain centric.
Cool. Yep. Let me share my screen. And then we can go back here. So, yep. Thank you everyone for another to attending to another class or lesson of Amplifying F# Essential Lectures. We briefly we covered the functional validation part, and next week we'll be covering the improving your data, your domain models, and we will be talking about value objects and more. So yeah, without further ado, oh, before I forget, so this Friday we have a session which is kind of relevant to what we discussed with what Ian showed us today. We will be having a session with Jimmy Bird, which is the maintainer of this library called FS Toolkit Error Handling, and he will be talking about what will be coming on version 5. And what's the reasoning behind some of the changes, and if there's any important stuff for that library, because this library is used. It's a really well known and really used library. So if you're curious about what is FS Toolkit Error Handling, join us for a session on Friday. So yeah, that's it from us, and thank you very much everyone for attending to the session. And yeah, I will see you next week. Bye bye.